In this video, we are going to take a look at the different polynomial operations. These operations are going to include addition, subtraction, and multiplication. We're first going to look at addition. I think this is probably the easiest one of the three. The reason for this is that the plus sign in the middle means that we're really just putting these two parentheses together. So what we're really doing is 3x squared plus 4x minus 5. And then we can just rewrite this second half of the equation that's right here. So that's just minus x squared plus 2x minus 4. Sorry, that says plus. Minus 4. So the plus sign just says that we're combining them. So then what I like to do is just circle my like terms. So I have a 3x squared and a minus x squared. 3 minus 1 is just 2x squared. Then I have my x's, so plus 4x and plus 2x. 4 plus 2 is 6. And then negative 5 and negative 4, put those together, and you get negative 9. And that's your solution. Is that simple? The only thing you have to be careful of is that sometimes if you look at an example like this, you'll notice that everything's not in the same order. So before, all of our x squareds came first, then our x's, and then our constants. And this one, it's switched up on this second set of parentheses. But it's still the same process. I'm adding, so I'm really just putting together my x squareds. 2x squared minus 4x squared is going to be negative 2x squared. I'm putting together my x's, so I have a positive 3x and positive 1x. That gives me positive 4x. And then I have negative 2 and positive 1. Put those together and you get negative 1. And that's your answer. So I think additions is going to be the easiest one. Really, you can just look at your like terms, put them together, see what you get. What you want to be careful of is when you have a subtraction problem. Because remember, when you have a subtraction sign directly outside of a set of parentheses, what that means is negative 1. So that's going to get distributed to everything inside of the parentheses. So all of those signs are going to flip. So we still have 5x squared minus 3x plus 4. But everything after that, negative times a negative is a positive. So you're going to have plus 3x squared. And remember I said we just really flip our signs. So it's minus 7x plus 3. And now we can just treat it just like the problems before. It's just that initial distribution that you have to make sure you do, and that you have to make sure you're paying attention to what's happening between those two sets of parentheses. So now I can do my 5x squared plus 3x squared, which is 8x squared. Then I could do negative 3x minus 7x, which is negative 10x. And lastly, I can do positive 4 plus 3, which is positive 7. And I have my answer. So that's addition and subtraction. They're really just about the same. It's just making sure that you distribute whatever is between the two sets of parentheses. When things get a little bit different is when you are doing multiplication. There's really two ways to do multiplication. Some people create like a little chart kind of like this, where they put x plus 3 at the top and 3x minus 4 on the side, and then they just create a little chart. So then I multiply just like you would multiply when you're doing larger numbers, when you were doing regular multiplication of constants. So I can do my 3x times x. That gives me 3x squared. And then 3x times 3 is going to give me 9x. X times negative 4 is negative 4x. And negative 4 times positive 3 is negative 12. Then I can rewrite that as 3x squared plus 9x minus 4x minus 12. And then you combine your like terms. 9x plus 4x is positive 5x. Everything else drops down. So you can do it that way, Or you can do it where you're just making sure you multiply everything in one set of parentheses by everything in the other. So when I say that, what I mean is that I can do x times both 3x and times negative 4. So x times 3x is 3x squared. I don't know why I put that in a highlighter. That's not going to work. Try that again. So x times 3x is 3x squared. X times negative 4 is negative 4x. And then I do it again, but now with my second term. So I do positive 3 times 3x and times negative 4. Oops. So 3 times 3x is 9x, and 3 times negative 4 is negative 12. And then once again, you combine your like terms. So either way you do it, you get the same answer. The array method is really good if you have trouble keeping track of what you're multiplying, is what I would suggest until you are super comfortable with what you're doing. And it works for however many numbers are in your polynomial. So if we look at our last example, we now have 3 numbers in our first set of parentheses and 2 in our second, but it's the same thing. I'm going to do the array method once again. So I have 2x squared plus 3x minus 1 times 4x minus 3. And I'll make my table, and then I'm just going to start multiplying. So 4x times 2x squared is going to be 8x cubed. 4x times 3x is 12x squared. And then 4x times negative 1 is negative 4x. Negative 3 times 2x squared is negative 6x squared. Negative 3 times 3x is negative 9x. And negative 3 times negative 1 is positive 3. Now, if you don't remember or you don't know how I'm getting these variables and the power that they're raised to, I'm just adding my exponents. So x to the first power and x to the second power, 1 plus 2 gives me 3. So that's all I'm doing. And then from there, I'm just going to write out everything inside of my box, and then I'll combine my like terms. So I have 8x cubed plus 12x squared minus 4x, and then I have minus 6x squared minus 9x plus 3. So my like terms, I have my squared terms, and I have just my x to the first power. So 8x cubed, 12x squared minus 6x squared is positive 6x squared. Negative 4x minus 9x is negative 13x. And there's nothing to combine that with. And then I have my answer. So that's it. That's everything you do for addition, subtraction, and multiplication of polynomials. Hopefully you found this helpful. You can find some practice online, get a hang of it, and go forth and prosper.